Dear students, today we will discuss about electric potential energy of a system of point charges. What do you mean by electric potential energy of a system of point charges? You remember, electric potential energy of a system of point charges is defined as the total amount of work done in bringing the charges from infinity to their respective places against the electrostatic force. First, we find the electric potential energy of a system of 2-point charges. For a system of two-point charges. Initially, you consider there is no external electric field. No external electric field. Here you have 2-point charges Q1 and Q2. Let the separating distance is R. So what is the potential energy of this system of 2-point charges? That is the total amount of work done in bringing the charges from infinity to their respective places against the electrostatic force. That means initially you assume there are no charges. You bring, suppose the charge Q1 and Q2 are at infinity. Now you bring the charge Q1 to its place. That means as there is no external electric field, so in bringing the charge Q1 to A, what is the amount of work done? As this charge Q1 will not experience any force, so work done is equal to 0. Now you bring the charge Q2 to its place B. What is the amount of work done? There is no external electric field, but electric field is set up at B due to this charge. That means due to this charge, you will get electric potential at B. So amount of work done in bringing the charge Q2 from infinity to B, the amount of work done is Q2, that is the charge, into potential at B due to the charge Q1. So potential at B due to the charge Q1 is 1 by 4 pi epsilon 0 Q1 by R. That equal to 1 by 4 pi epsilon 0 Q1 Q2 by R. Let it be equation 1 and it is equation 2. What is the net work done? Net work done is equal to W1 plus W2. That equal to W1 is your 0 and W2 is this 1 by 4 pi epsilon 0 Q1 Q2 divided by R. That equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R. This work done gets stored in the system and appears as electric potential energy. Therefore, electric potential energy, that is 1 by 4 pi epsilon 0 Q1 Q2 by R. You see, this, if the two charges are of like nature, that means if both are positive or if both are negative, then the product is positive. Then potential energy is positive. Potential energy positive, that indicates the electrostatic force between the two charges is repulsive. You write in note 1. Potential energy positive means the electrostatic force is repulsive. If both the charges are of unlike nature means if one is positive, the other one is negative. then what is the product? Product is negative. That means potential energy is negative. Potential energy negative, that indicates the force is attractive. There is electrostatic force between the two unlike charges, between the two charges of opposite nature is attractive. Then the potential energy is negative. Now come to for a system of 3-point charges. For a system of three-point charges, it is A, B, C, Q1, Q2 and Q3. Let the distance between Q1 and Q2 is R1, 2, R2, 3 between Q2 and Q3, and between Q1 and Q3 the distance, let it be R1, 3. What is the potential energy of the system? You bring the charges from infinity to their respective places and you see what is the total amount of work done. There is no external electric field. Now you bring the charge Q1 from infinity to A. What is the amount of work done? W1 is equal to 0. As there is no external electric field, it will experience no electrostatic force, so work done is 0. When you bring Q2 from infinity to this point, then what is the amount of work done? The amount of work done is due to the electrostatic force experienced by this charge on this charge. So W2 that equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12. Let this equation be 1 and this equation be 2. When you bring Q3 charge from infinity to this point, what is the amount of work done? W3, there is no external electric field, so work is not done by against the external electric field, but work has to be done against the electrostatic force experienced by this charge and by this charge. So by this charge it is 1 by 4 pi epsilon 0 Q1 Q3 by R13, and against the electrostatic force experienced due to this charge, that is 1 by 4 pi epsilon 0 Q2 Q3 by R23. Therefore net work done W is equal to W1 plus W2 plus W3, that is equal to 0 plus 1 by 4 pi epsilon 0 Q1 Q2 by R12 plus this, that is plus 1 by 4 pi epsilon 0 Q1 Q3 by R13 plus 1 by 4 pi epsilon 0 Q2 Q3 by R23, that equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12 plus 1 by 4 pi epsilon 0 Q1 Q3 by R13 plus 1 by 4 pi epsilon 0 Q2 Q3 by R23. This amount of work done gets stored in the system and appears as electric potential energy. Therefore, potential energy usual W, that equal 1 by 4 pi epsilon 0 taking common Q1 Q2 by R12 plus Q1 Q3 by R13 plus Q2 Q3 by R23. That means it is the electric potential energy of the system of 3-point charges. You see here, we have taken all possible products. That means we have to take for the system of 3-point charges 1, 2, 1, 3, then 2, 3. Similarly, if you have a system of 4-point charges, if you have a system of 4-point charges Q1, Q2, Q3, Q4, then potential energy of the system will be 1 2 U1 2 plus 1 3 U1 3 plus 1 4 U1 4. Now come to 2 U2 1, but we have taken 1 2, so you cannot take U2 1. Then U2 2 you cannot take because a charge cannot exert force upon itself. That's why you cannot take U2 2. Then U2 3 plus U2 3 plus U2 4. Now come to third charge. U3 1, already we have taken 1 3. Then U3 2, already we have taken U2 3. You cannot take further U3 2. Then U3 3, you cannot take U3 3 because a charge cannot exert force upon itself. Then U3 4. That means that if you come to Q4, that is U4 1, already we have taken U1 4. Then U4 2, already we have taken U2 4. U4 3, already we have taken U3 4. U4 4, you know U4 4 you cannot take. So it is the potential energy of the system of 4-point charges. So what do you mean by U12? That means you have to take the potential energy between Q1 and Q2. That is 1 by epsilon 0 Q1 Q2 divided by this distance. Similarly, U13, that is the potential energy between Q1 and Q3. That is 1 by 4 by epsilon 0 Q1 Q3 divided by this distance. In this way, you will find the potential energy of a system of point charges. These expressions we have got in absence of external electric field. But if there is external electric field, then what is the potential energy of the system of point charges? For a system of 2-point charges, we will find the electric potential energy in presence of external electric field. It is A, it is B. Suppose you have the charge Q1 at A and Q2 at B. Let the distance between them is R. The concept is same, that is the total amount of work done in bringing the charges from infinity to their respective places against the electrostatic force. That is, to bring Q1 and Q2 from infinity, we have to see what is the amount of work done. Let it is the external electric field. When we bring Q1 to A, then here we have to do work against this electrostatic field. Then W1 will be Q1 into V1. What is V1? Where V1 is electric potential at A due to external electric field. Now you bring Q2 from infinity to the point B. What is the amount of work done? In bringing Q2, the amount of work done is first the amount of work done against the external electric field and work done against the electrostatic force experienced due to this charge. That is W2 is equal to Q2 V2. V2 is the electric potential at B due to the external electric field plus the work done against the electrostatic force due to this charge. That is 1 by 4 pi epsilon 0. Already we have derived this Q1 Q2 divided by R. It is only question number 2. Therefore, the net work done W1 plus W2, and you remember this V2, where V2 electric potential at B due to external electric field. W1 plus W2 that equal to Q1 V1 plus Q2 V2 plus 1 by 4 pi epsilon 0 Q1 Q2 by R. It is the net work done in bringing the charges Q1 and Q2 from infinity to their respective places in the external electric field. This work done gets stored in the system as electric potential energy. Therefore, electric potential energy Q1 V1 plus Q2 V2 plus 1 by 4 pi epsilon 0 Q1 Q2 by R. In this way, also you can find the electric potential energy for a system of 3 point charges in the external electric field. This question has come this year in the board examination, class 12 board examination, and it is very important topic. Definitely you will get 1 to 2 questions in the board examination.